Welcome America, India, and Selena Gomez to live studio recording in 202. Today it is dressed like a student day. So I have the middle part and I have the messy bun. And I'm just gonna walk around all day. I've already this morning done this and walked up to teachers and been like, bruh, are we doing anything in class today? Can I borrow a pencil? Okay, so without further ado, here we go. We are going to do some review for our right triangle unit in geometry. We're going to start with simplifying radicals, quick review, and then we are going to we're going to look at a couple problems to determine it's the converse of the Pythagorean theorem to see if when we have the lengths, 3 lengths of a triangle, if it actually forms, if they can form a right triangle. So here we go. So problem number 1, we have a root 3 in our denominator. And when we get an answer, sometimes we need to rationalize the denominator. In higher math, you'll end up having to sometimes rationalize the numerator, but it's another skill we're gonna put inside our math toolbox. And here we go. So to rationalize the denominator, we're gonna multiply by special 1. Here is our special 1. Doesn't change the value of the expression if I multiply by root 3 over root 3. But now the denominator becomes, what's root 3 times root 3? 3. Okay, now we've rationalized the denominator. Now we multiply across the top. We've got 10 root 3. Then we take a look at what we have, and 3 doesn't go to 10 evenly, so we are finished. Any questions? Okay, I'll leave it. For problems 2 and 3, we just have to look and see if the 162 is simplified and the 24 is simplified, if there are any perfect square factors that go into those numbers. So I've written up perfect squares here that we might take a look and use. Do any of these numbers, what's the highest number that goes into 162 evenly? I think it's 81. And I think 4 goes into 24. You tell me, you guys have already done these problems. Is that 81 times 2? Okay, and then 24 should be, we'll put the 4 first because there's a perfect square. 4 times 6. The reason I broke up 162 into 81 times 2 is because 81 is a perfect square factor of 162, and now we can find the square root of 81. The square root of 81, when it comes out, is 9. Right, and the root 2 is, the 2 still under the radical. So this is just going to be 9 root 2. Questions? 4 is a perfect square. It's the largest perfect square that goes into 24 evenly. So we pull the 4 out. Square root of 4 is 2. So when it comes out, this is 2 times 5 root 6. So that's 10 root 6. 6 is not a prime number, but there are no perfect square factors of 6. 2 and 3 multiply to give you 6, but 2 nor 3 are perfect squares. So we're done. Any questions? Okay, now we take a look when we are given a set of numbers, 3 lengths, and we're asked to see if it forms a right triangle. So we are going to use Pythagorean theorem. You'll see problems like this, really similar to this, on your SOL. You have to just make sure, Pythagorean theorem, the largest number is c, right? So c squared equals a squared plus b squared. When you look at your 3 numbers, the largest number has to go in for the 25. Or sorry, for the c. So we're gonna have to put in 7 and 24 for a and b, and 25 for c. So then we take our calculator out. Does 25 squared equal 7 squared plus 24 squared? Has anyone done these problems? Does 7 squared, does that equal 5 squared plus 4 squared? Notice I put the 5 first here and the 4 second, and I put the 7 first here and the 24 second. Doesn't matter, right? We're just squaring them and adding them together. 17 has to be the c for number 6 because it's the largest length, longest length. So I'll put 17 for c. and the 8 in, and the 15 in for A and B. Now we just take the calculator out. Bruh. We just take the calculator out. Does 25 squared equal 7 squared plus 24 squared?
Yes.
Yes. So check yes. Determine if the set of numbers could represent the sides of the right triangle. Yes. Does 7 squared equal 5 squared plus 4 squared?
No.
Does 17 squared equal 8 squared plus 15? That's a squared.
Yes.
That's it.